Hey everybody, Trey here. Welcome back to another forecast discussion. This is going to be kind of our last major day in this kind of multi-day severe weather outbreak sequence we've had here over the past couple days. Today we have a big old slight risk here from up toward the eastern North Dakota, western Minnesota area, all the way down through Iowa, eastern Kansas, western Missouri, and then down into central Oklahoma. Kind of a bimodal tornado threat today. There's a 5% up here for kind of that South Dakota, North Dakota, Minnesota triple point there, in kind of a cold core-esque setup. We'll talk about that in this video, of course. And then a separate area of enhanced tornado potential down along the dryline slash cold front here from southeast Kansas into central and southern Oklahoma, including the Oklahoma City metro area. Damaging wind will be a threat today as well as large hail. So let's go ahead and get started. We're going to cover both of these kind of two different areas of enhanced severe weather potential in this kind of broad slight risk area today in this video. So let's start here, and if you are a weather weenie, you really get excited when you see satellite images like this. This is some satellite porn, if you will. Just an absolutely beautiful satellite depiction here of this low pressure system that is in the process of kind of occluding here. You can see this kind of comma shape. It is in the process of kind of occluding here as it moves off toward the northeast. But in all, a big old trough here with kind of the main sort of center of circulation kind of up here into the Dakotas right now, and it's going to continue to occlude and move off kind of toward the northeast as we go throughout the day today. We still have a kind of broad fetch of this southwesterly flow here in this sort of broad long wave trough here that is going to be of assistance here in the southern portion of the target area for today. You can see we've already fired we're continuing to fire some convection out here out ahead of this very potent system here. If we look on radar, you can see we've got storms ongoing into central Minnesota right now, down into even parts of southeast Kansas, northeast Oklahoma. It's kind of the remnants of that squall line that formed last night out here into the Texas Panhandle, moving off toward the east. That still remains, but should not be an issue for convection later on today. These storms are kind of few and far between at this point and weakening as we go through the morning hours here, so should not be an issue for storm development later on today. Let's look at our visible satellite imagery and more satellite porn. Just beautiful, beautiful depiction of that system here on this visible satellite image. You can see some cloudiness here into the southern plains. You can see that return flow trying to make its way into the southern plains. We've had a little bit of a difficult time getting this ample moisture here that's residing here in South Texas into the Gulf, into the southern plains with this system. Partially because we've had a little bit of a ridge that's been blocking the return flow down here into the southeast. But nonetheless, we have 60s dew points down here into South Texas, and you can see that return flow of the flow out of the south really starting to make its way onshore here. And you can see those storms and ongoing convection up here into Minnesota, down through the Midwest into the southern plains there as well. So let's take a look at our surface map here. We're going to start with the southern plains portion of this severe weather threat. So here we have, you can see upper 50s dew points out here into the Oklahoma City area, with 60s down by the Red River, and kind of mid 60s down here along the I-35 corridor down toward Waco, Austin, Round Rock areas. Again, the best moisture going to be confined to that Texas Gulf Coast, upper 60s dew points here. We just really haven't gotten this moisture to spread inland with this setup. We've kind of struggled here with low-level moisture in this setup and moisture quality overall. If you recall yesterday, our moist layer on the soundings was very, very shallow. And we kind of had some mixing out here in the Panhandle. Dew points kind of cratered into the upper 50s there. So moisture has been definitely an issue with this system. And today that may be the case as well, although we should see at least low 60s dew points, perhaps mixing a little bit into the upper 50s here as we go through the day today, out east of this kind of cold front dry line kind of combination. I would tend to call this more of a cold front here. You can see temperatures on the west side of this wind shift are definitely cooler than they are on the east side. Normally, if this was a pure dry line, we would see perhaps warmer temperatures out here on the west side of this, along with the lower dew points here. So would suspect that this is kind of a cold front, perhaps cold front kind of dry line combination there. That is going to be our main focus for storms down here in the southern portion of this outlook area. Let's go off toward the north now, and we'll go up here into Minnesota. You can see very strong winds here out ahead of a very well-defined surface low out here into South Dakota here. Surface low there, strong southeasterly flow out to the east and southeast of that. And so we're going to have this kind of not modest moisture, but at least decent moisture pumping up into Minnesota and this kind of South Dakota, North Dakota, Minnesota triple point area for today. Low 60s, upper 50s to low 60s dew points up here. Going to be more than adequate given the kinematics and dynamics aloft, which we'll talk about here in a second. So we're not seeing these upper 60s dew points here with this setup that would be at least a little bit more favorable for severe weather, but the moisture is going to be adequate, I think. Not going to be a total deal breaker here for this setup. So let's take a look at our upper air maps. This is our 500 millibar map here on SPC mesoanalysis, so about 18,000 feet aloft, and you can see really, really wrapped up trough here. Strong flow here, kind of rounding the base and the side of that trough here. Beautiful defluence aloft. We've talked about defluence a lot here in the last several videos, but look at how these wind vectors and these height contours spread out with height. That is just absolutely beautiful. When you get that, that is associated often with rising motion, because when air, again, spreads out aloft, it creates a void. So when there's that void, the atmosphere wants to fill that void, and what does it do? Well, it takes air from below and tries to fill that void above, so it promotes rising motion. So when you have defluence aloft like this, usually that is associated with the exit region of the trough, very strong rising motion in this case. Farther south, you can see this kind of how this trough is very sort of elongated here, kind of a high wavelength here with this trough. And there may be a little bit of a short wave in here that may assist this southern plains portion of the outlook today. As you can see, the main forcing is definitely off to the north here, so storms up here should not be an issue as we go through the day today. And given one more thing, given the long sort of wavelength of this system, and wavelength, we go from crest to crest or trough to trough, so very kind of long wavelength here. And when we have longer wavelengths here of these systems between the associated trough and high pressure here, these tend to move a little bit more slowly. So this should not move a whole lot toward the east today. I would expect this to end up somewhere up here as a rough kind of estimation today, this 500 millibar kind of closed cold core system. It's not going to move off to the east a lot as we go through the day today. It's more so going to eject a little bit off to the northeast and move kind of in this region as we go through the day today. Down south here again, we're still going to see this kind of strong flow aloft and maybe some embedded short waves in the flow. Let's go down to 700 millibars and see if we can pick out the short waves here. So you can see one kind of right in here. That's going to be our main player for this northern severe weather threat today. But you can also see one back in here along kind of that eastern Colorado, eastern New Mexico area. And that should move off to the east slowly throughout the day today. And that could be the impetus for storms later on down here into southeast Kansas, central Oklahoma, down toward the Red River area. So we're going to have to watch that closely. And if we can try to see if we can see any shortwaves here on the water vapor imagery, sometimes that's a really good tool to help us depict any shortwaves in the flow. And I'm not really seeing a whole lot in the way of that. It's a very subtle sort of shortwave, so we're going to have to rely on the 700 millibar map here, and I think this one definitely may be the impetus for storms later on here in the southern plains today. Low-level jet, very strong low-level jet across a pretty wide expanse of the country here today. You can see 40s plus down here all the way into South Texas here, extending into the Midwest, with kind of your maximum out here into eastern Kansas, Missouri, into Iowa here, 60 knots or so there. So very strong low-level jet out of the south or just south-southwest there. So very strong winds just about a kilometer above the surface. And that should maintain today, given this very strong circulation here and continued kind of flow across the Rockies, kind of maintaining that surface low development on the east side of the Rockies here. So a very potent setup for sure, very strong low-level jet. And here's our surface pattern right now. So we have that surface low out here into kind of eastern, southeast South Dakota there. Kind of our warm front somewhere up in this region. Kind of hard to tell from just the pressure kinks in the isobars there. Perhaps warm front in there, trailing cold front going down here. And again, kind of hard to depict here from just the surface map, but again, on the station plots, we saw that our cold front kind of sits somewhere in here. We have that kind of maybe a secondary low circulation in here with kind of a cold front in kind of that pressure tongue right there as well. So very complex surface pattern here, but you can see here we have this surface low up here for the northern target. The 500 millibars is going to be very in close proximity. So this is a pretty classic cold core situation for today, for up into that Dakotas, Minnesota area. You can see here, we've talked about this many times before. You have your 500 millibar closed circulation there. You have your surface low kind of in close proximity. You have your kind of cold front or kind of moist axis leading up into that low, kind of feeding back into the surface low. And then right on the apex of that surface low, the kind of triple point between that cold front or moist axis and that warm front is where the most favored location for tornadoes are. This is from Davies and Geyer 2004, kind of the foundational work on cold core setups. So very common cold core setup today. And if we have decent low-level instability, which we'll talk about here in a second, could be a pretty solid tornado day up there in that Dakotas, Minnesota area. So let's take a look at some soundings now. We'll start here with the Southern Plains. This is our Norman sounding from 12Z, and you can see a very stout elevated mixed layer, very stout capping inversion on the environment today. So our moist layer has gotten a little bit deeper since yesterday. We've gotten a little bit deeper, up to about 850 millibars here. Still struggling with fairly meager dew points here from a severe weather perspective. Still adequate for sure. 68 over 59 here at 7 a.m. at Oklahoma City, but very, very stout cap on the environment. And so that may be a little bit stubborn to break. That shortwave may help. Heating along that dry line and convergence along that dry line today, dry line / cold front, will help assist in breaking this cap, but looks like a pretty stout cap and may be difficult to break here as we go through the day today. So we're gonna have to watch that for sure. That's a pretty stout cap just by looking at it. Very, very dry, very warm air between about 700 and 850 millibars here. We do see some steep lapse rates aloft, so large hail may be an issue today with any storms that do form. Strong warm advection ongoing, and we've had, if you live in the plains, we've had these very, very strong winds in place since yesterday, and we've got this veering of the winds in the lowest couple kilometers here. Very strong warm advection near the surface. Low-level jet at here in Norman at 7 a.m. was between 50 and 60 knots here, so very, very strong flow just above the surface, helping to aid in that warm advection in these very strongly clockwise curving hodographs. Would expect that to maintain itself again throughout the day. Low-level jet may come down some, but we should keep these decently curved low-level hodographs throughout the day. Let's go ahead and go up to the northern target right now. So this is going to be, let's go here to Aberdeen, see what's going on. Fairly moist profile here, which is in contrast to what we've seen the last few days here across the southern plains. A little bit of a capping inversion there in place. A little bit of an elevated mixed layer. Steep lapse rates aloft, so large hail going to be an issue. This cap looks a lot more breakable, though, than the one we saw in the southern plains. Very interesting wind profiles aloft here. Not quite sure what's going on there. But here in the low levels, decent curvature already. Well, not so much. Looks like decent curvature, but pretty wonky wind profiles there. I'm not quite sure what's going on at Aberdeen. So let's go ahead and go over to Minneapolis here, and that's a little bit better depiction, I think, of things. Strong curvature in the low levels, strong low-level jet in place all the way up here into Minnesota. Some capping in place for sure, but a fairly deep sort of moist layer there. Not your kind of traditional moist layer there, but decently moist there up to about 800 millibars with that capping inversion aloft, elevated mixed layer, steep lapse rates, large hail going to be an issue with these storms, especially if the 500 millibar temperatures are as cold as a typical cold core setup. And if we go back to our 500 millibar map here, we see these red contours are our temperature contours. So we're seeing, upwards, this is 16, 18, minus 20 degrees Celsius. So some pretty cold air aloft associated with this system. It's going to help build instability as we go throughout the day. We already have pretty strong instability in place here at least from the most unstable parcel. The mixed layer parcel is struggling there. Not much instability yet, but that should change as we go throughout the day today up in that area. So let's go ahead and look at some model data. 12Z NAM here, hot off the press. So you can see that depiction of that low. You can see how it occludes as you go through the day today. So that kind of main lobe here with this system kind of occludes off to the northeast, and you see it doesn't move that far because this is such a kind of very long wavelength sort of system. You can see it doesn't move a whole lot throughout the day. This is going to be 4 p.m. and it really hasn't gone that far, at least the center of that closed circulation there at 500 millibars. But so our 500 millibar circulation right in here, the center of that circulation there, our surface low going to be in there. So this is our 500 millibar. Put a 5 there for that. And this is our surface low here. So in very close proximity, you can see that warm sector feeding up into that surface low, and so the favorite area for tornadoes is going to be somewhere right in here, kind of that North Dakota-South Dakota-Minnesota triple point there, in a pretty classic sort of cold core setup. You can see meager dew points kind of pool along that front there up into Minnesota. So pretty decent cold core setup today. Would expect to see several not several tornadoes, but these cold core setups tend to be sneaky and produce quite efficiently. And we've talked about this before. You don't need a lot of low-level shear to produce tornadoes in this setup because the low-level instability tends to be very, very high in these setups. That's a little bit contaminated there. Let me pick another sounding here. Let me go a little bit farther south. But because the low-level instability tends to be pretty high in these kind of setups, any spin in the low levels is going to be quite efficiently pulled, stretched up into the vertical. You can see here at 4 p.m. 123 0 to 3 kilometer cape there. So very strong low-level instability, decent curvature in the low levels. And again, you don't need these Mongo hodographs to produce tornadoes in these kind of setups. This is pretty classic. And these tornadoes are going to be highly visible. You can see how well the upper level winds are going to vent that precipitation off away from the mesocyclone. So if you can kind of depict a supercell here, the precipitation is going to be vented off toward the north. And so these tornadoes, if they do happen here, will be very, very visible, as is the case in a lot of cold core setups. And if we go toward 0Z here, as that low kind of lifts off into northern Minnesota there, we'll see what the profile looks like. And yeah, pretty solid. A little bit of convective contamination, but it's still a decent profile here to take a look at. And you can see here, 0 to 3 kilometer cape, 226. So this is just a very classic cold core setup, and pretty decent shear in the low levels here. Maybe a little bit influenced by the convective signal here, but very solid shear in the low levels. So a few tornadoes definitely in play here for eastern North Dakota, eastern South Dakota into kind of west central Minnesota today. Again, decent instability here, fairly low to moderately topped convection here because we don't have these very, very tall sort of cape profiles here. So maybe somewhat low topped convection here, but steep lapse rates aloft will favor large hail as well as the tornado threat up there in that region. So as we go down south here, you can see that we do get that dry line to really set up here across the plains. It is a slanted dry line, and I've never been a fan of slanted dry lines like this, often because your shear vectors are more parallel to the initiating boundary, and as such you get a more messy storm mode. But that may not be the case today. I'm going to zoom in here to our Southern Plains sector and kind of show you. First off, let's look at for any shortwaves here. That little shortwave that was kind of tailing back into kind of the New Mexico area there, and not seeing a whole lot of anything here on the 12Z NAM here. Maybe a little bit of something, a little bit of kink in the flow there. That maybe that shortwave we were pointing out on the 700 millibar map. This may be a little subtle shortwave, may help initiate storms here. As the main sort of forcing goes off toward the north, this may be exactly what we need to get storms to go here along the dry line, as well as the convergence along the dry line. If we look at our surface map here, so we have pretty solid convergence along that dry line. You can see it was located somewhere kind of in here. We have southwesterly winds on the west side, southerly winds on the east side of the dry line. That may be just enough convergence here along that dry line circulation to assist in getting storms to fire here into central Oklahoma. But this is a very solid depiction of the moisture here. We do get, actually on the NAM here, mid-60s dew points up into central Oklahoma here. I think that is going to be plausible. We're going to have this kind of strong surface flow maintain itself throughout the day, 20, 25, 30 knots here at the surface here. And you can see where those 60s dew points are, those mid-60s dew points are. And so I think it's definitely plausible that we could get these dew points up to the east of that dry line here by mid-afternoon. So definitely something we're going to have to watch. We may have a little bit of mixing here. I do expect that this capping inversion will keep mixing at bay a little bit because this is a very, very strong cap. This is going to provide a lid and not going to allow vertical mixing to happen, perhaps as vigorously as would be otherwise expected. So I think getting these low to mid 60s dew points up into the east portion of east of the dry line here is definitely plausible today. And if that's the case, I think we're going to have a decent shot for some supercells here with tornadoes. Given that little forcing from the shortwave, forcing from the dry line, would expect to see a supercell threat here evolve across perhaps central Oklahoma, including the Oklahoma City metro area. Let's take a sounding here at 21Z, 4 p.m. Central Daylight Time. See what we're seeing. So the NAM remains pretty capped here at 21Z. Surface temperatures, though, as we have always pointed out here on the NAM, 74 degrees here at the surface. So I'm curious here, if we go to the Oklahoma Mesonet, so Norman forecast high today is going to be 79 degrees, and I think that's plausible. And so this is about 4 p.m., so this would be about our high temperature. So if we take this and we say we're at 79 degrees here, so we move that a little bit forward, dew point's at 65, we take our surface-based parcel here and lift it up, and you can see by that point we're probably going to be pretty close to uncapped if we get up to into the upper 70s, low 80s today, which once we get sunshine going here into the central Oklahoma, I think that's more than possible here. You can see the moist layer deepens throughout the day, so that's a good sign, something we haven't seen over the past couple of days. Moist layer gets up to about 800 millibars here at Oklahoma City on the NAM depiction of the setup here. So interesting here, if we can get this cap to erode fully, we're going to have the potential for supercells here along the dry line. You can see very strong curvature in the low levels, very strong low-level shear, effective helicity of 301 meter square per second squared. So very much a supercell wind profile here. As we go toward dark, that dry line starts to tighten there a little bit. So this is a somewhat concerning look here for these southern plains. Let's go into southern Kansas first. So wow, southern Kansas, the NAM completely uncaps southern Kansas, 0 to 3 kilometer cape of 197 there. That is pretty eye-opening. Very solid cape profile there, over 2,000 joules per kilogram of cape. Large looping photographs in the low levels. A little bit of a weakness here in the mid-level flow there. I think if we can attain that we're going to get a discrete mode, I don't think that's going to be too much of an issue, as it is above the effective inflow layer. May make things a little bit more grungy as the mesocyclones will move kind of into their forward flank precipitation region. Wow, okay, this is pretty interesting here. So at 7 p.m. we get up to 78 degrees here on the NAM, and we are more than uncapped, completely uncapped here. It looks like very strong low-level instability and a very kind of tall cape profile, maybe a little bit skinny, but still a solid cape profile. 2,500 joules per kilogram of cape and large looping photographs here. Large, long photographs, large looping photographs in the low levels. This would definitely be a tornadic supercell kind of profile if we can get semi-discrete convection along the front. And again, I think given the subtle forcing here, perhaps from the dryline circulation and the shortwave here, and we'll see if how our shear vectors do. Wow, so very interesting here. This is our dry line. You can see our shear vectors are quite perpendicular to that dry line. So this is a little bit of a concerning situation on the NAM, at least, for this afternoon for parts of southern southeast Kansas down into west central Oklahoma here. If we do have enough forcing to overcome that cap and get semi-discrete storms to fire, which I think the mode will be semi-discrete, they would have the chance of producing tornadoes here, along with large hail and damaging winds. But the tornado threat definitely is in play today for central Oklahoma. in particular here if we can get storms to fire. And again, that's going to be the thing. If we can get storms to fire, which I think is going to be more than plausible here, given a very tight dry line, strong convergence along that dry line. If we do have that shortwave in play, that will be very helpful. So I think a few supercells along the dry line definitely in play here for the southern target. So we're going to have to monitor things very, very closely as we go through the day today. Just want to look at the wrap here just to kind of look and see how it's depicting the dry line. Because we've had some discrepancy in the actual dry line and how tight it's going to be and that moisture advection to the east of that dry line throughout the day today. So let's go ahead and zoom in here. Just so we're kind of doing a little bit of model kind of comparisons here. And so I think the wrap is definitely overdoing moisture here, upper 60s dew points. I'm not sure that's going to happen, but it does have a pretty wide swath of low to mid 60s dew points here to the east of that dry line. Very, very tight dry line here as well. So the wrap is kind of on board with this similar scenario. I'm going to take a sounding at Oklahoma City here, see what the wrap is showing, just for some comparison here so we can get some model agreement here. So let's take a look at the sounding here, and it's showing much of the same, a little bit skinny of a cape profile here, so not the most favorable for robust convection here, but it is uncapped here by 0Z, 78 over 62. That's, I think, a decent depiction of the low-level thermodynamic profile. Long hodographs, large looping hodographs in the low level, so this would promote perhaps supercell development. Again, the skinny cape profile, not quite what we like to see for a tornado event, but nonetheless, it is uncapped, so that will be something to watch for sure as we go through the afternoon hours today. So finally, let's wrap up here with some of the cams, just kind of get you see kind of an estimation of what the radar might show. So this is the southern portion of the target, and you can see by 23Z, 6 p.m., we do get kind of a broken line of storms to fire here from the Red River area, kind of the Vernon, Wichita Falls area, up through kind of much of central Oklahoma, the I-44 corridor, and eventually approaching the I-35 corridor by early evening. So you can see it kind of maintains that broken line here, where it's not a solid squall line here. So these would have the potential to produce large hail, damaging winds, and a few tornadoes if we can get that robust instability profile to build in this evening. Let's go up to our northern target here. So up into the Dakotas and Minnesota. And I would expect this to be your kind of classic cold core sort of event, sort of look here on the radar. We get kind of this arc of supercells here. And so the HER not showing as much here. Again, I don't know if I buy that here. This may be your this may be your storms right here. Perhaps an arc of supercells just ahead of that surface low, aided by that cold air aloft. So these would definitely have a tornado threat given steep low-level instability, and as well as a large hail threat with these storms. So let's take a look at the WRF ARW. We'll start now with the northern target here. Just kind of going through the cams and seeing how the agreement looks. So it kind of has this separate area of storms out here, kind of along the moisture axis, out here into southern Minnesota, down through the Midwest, down into eastern Kansas there. So some storms definitely possible here. Perhaps an outside chance of a tornado or two, large hail and damaging winds, the main threats up here. ARW not showing a whole lot in the way of that cold core convection, but again, these models don't really handle these kind of cold core setups well at all. Let's go down to our southern plains target here, and wow, so ARW firing a couple of supercells here near the Oklahoma City metro area by 6 to 7 p.m. here. So this is definitely something to watch. And again, I think the storm mode will be semi-discrete here at the very least. And so definitely going to be something to watch for the Oklahoma City metro area. Oklahoma City, Moore, Norman, and surrounding areas. Going to have to keep an eye out for isolated supercell development later on this evening with an all severe hazards threat. So finally, NSSL WRF. We'll take a look here. This is going to be our final model, and very interesting here. The NSSL WRF does fire storms along that dry line. Isolated, semi-discrete storms here. Supercells along that dry line approaching the I-35 corridor by 7 to 8 p.m. So going to need to watch out for that even up towards northeast Oklahoma, Tulsa, Bartlesville area perhaps, and then along down that dry line down toward the I-35 corridor, including Oklahoma City there. So very interesting setup here in the southern plains. Again, going to have to watch how much instability does end up building and whether that cap can erode or not. We'll go finally up here to our northern plains severe threat, and you can see kind of that arc of convection. Not really showing a strong signal for supercells up here, but again, these models don't handle the cold core setups that great. So would expect to see kind of an arc of supercells here just ahead of that surface low with a large hail and tornado threat with those storms. So that's all I have for now. We, again, slight risk here, big slight risk. If you're in the slight risk area today, take the weather seriously today. Again, the most probable regions for severe weather and enhanced tornado threat is going to be the kind of I-44 and I-35 corridors, into south central Oklahoma, up north toward the Tulsa area into southeast Kansas, and then that kind of cold core setup up there in the kind of South Dakota, North Dakota, Minnesota triple point area this afternoon and evening, with the damaging wind and hail threat for areas for those areas and areas in between as well. So with that, thanks for watching, and we will see you in the next video.